All right, so the quiz is coming not tomorrow, but the next day, on Wednesday. Then Thursday, we have a day of review. You guys have a long weekend after that. You come back, we have one more day of review, and then you have the cumulative test, which basically covers everything you've learned since the beginning of the year. Except for the very beginning of the year algebra stuff. That's not on there. It's the stuff since we started real Precalc. All right, so let's talk about what we've been learning lately. They'll be on this quiz that's coming up. First thought, you're going to need to know. Is this graph, what is the range of that graph? Negative infinity to positive infinity. It's how low to how high. How about this one? What's the range of that graph? 0 to infinity. It's how low, 0 to how high, infinity. How about this one? It's the most commonly screwed up one. This has got an asymptote just in case it isn't clear. It goes up forever. The domain of this one or the range of this one? The range. The range is how low will it ever be? What's the lowest it'll ever be? Negative infinity. How about the highest it'll ever be? Positive infinity. So it is negative infinity, positive infinity. Okay, you could easily mess that one up though. How about the domain? Is the domain negative infinity to positive infinity? No, it's not. Because it doesn't go forever this way, does it? Domain, how far does it go that way? 0. Does it actually touch 0 if there's an asymptote line there? No, so it's from 0 to how far this way? Infinity. Even though it's going downwards, that's not the point. Domain is like this. So the domain of this one would be from 0 to infinity. All right, that's domain and range. How about domain and range without a picture? What if it's like this? 1 over x plus 5, x minus 4. Do you get that 5 and 4 are important things? They make asymptotes. And so therefore they also crash the function. If you put in a negative 5, it will crash. And what does that mean? That means negative 5 is not in its domain. The domain is everything except x cannot be negative 5 and x cannot be 4. Those are the two things that it can't be. So its domain would be, I could draw it out on a number line, probably easiest. Empty spots, and then it works everywhere else. Okay, what if I throw in a square root? Square root of x plus 3 over x minus 5. Now there's an important spot at 5 still, because 5 would crash it. But there's also this little x plus 3 has to be what? Greater than or equal to 0. Because remember, the top can be 0. It's okay to have a square root of 0. That's all right. All right, so then this one would be x is greater than or equal to negative 3. And then this part here is x cannot be positive 5. And then I'd put those on a number line, and then how would I check the rest of the parts? Here's negative 3, here's 5, and 5 does not work, and 3 does work because I look at this sign right there. And then how do I check this spot, and this spot, and this spot? You test intervals, and you check and see if it works. Okay, that's domain. I want you to do one like that. Ready? X minus 4 over x plus 3. Tell me what the domain is of that puppy. One of the things you should have said was that x minus 4 needs to be greater than or equal to 0. If you don't have that off the top of your head, then you need to start studying now for that test that's happening 2 days from now. How do you do that? There's a lot of review problems on tonight's homework. They're great practice for the test. Make sure you take the time to learn them. Don't just copy off answers off the internet. At least check the answers and then look at the work. See what you're missing. X plus 3 cannot equal 0. So x cannot equal negative 3, and x greater than or equal to 4. Those seem important. I'm going to put them on a number line. Here's negative 3, here's 4. This one works, this one doesn't. And then I test my little intervals. I tell you, most kids can do this part. So if you think, oh, I'm good, I got that far, you're going to make your mistake on testing intervals. So take a minute right now and test your intervals, and we'll see if your intervals come up the same way as mine do. So test 0, see if 0 works. Test 5, see if 5 works. Test -5, see if -5 works. Okay, here's 5. Put in the 5 on top. Does that cause a problem? Does this cause a problem? No, so therefore it works. How about something between here and here? Ooh, my favorite thing, 0. Does that cause a problem when I put the 0 on top? Yes, it does, because I have square root of a negative. Can't do that. That's out. How about like -5? I stick in the number -5. Is that going to be okay? -5 minus 4 is -9. Square root of -9. So bottom line is from 4 to infinity is the, what did we just figure out? The domain. All right. So I'm going to back up to the beginning of the problem of what if it had not been a domain question? What if they'd have said, what are the horizontal and vertical asymptotes? Remember the Bob thing? Those are the Y things.
How come it's only 4 to...
How come it's only 4 to infinity? Because I'll redo all those notes that I did there. Because when I checked 0, 0 didn't work because it gave me a negative on top. And I checked -5, that didn't work either. So nothing over here works. From this whole area, all doesn't work. That's why it's only from 4 to infinity. All right, back to this problem. And let's say it was a horizontal and verticals. Remember, Bob tells you the horizontals. And you remember, I gave you this lame way to remember it, the horizontals. But when they ask you for the horizontals and you put X things, you will get it wrong. That's why I'm trying to pound it into your head that the horizontals are Y things, horizontals. And what are the other ones then? Verticals. And if they say put the horizontals here, then you better have what kind there, Y or X? Y. And who tells you Y? Bob tells you Y. Is this bigger on bottom, bigger on top, or same on both? That can be a hard one for people if they don't know that that means to the 1/2 power. That's what square root means. Didn't know that? Learned it now. Square root means 1/2 power. So that's to the 1 degree. So 1 degree is bigger than 1/2 degree. It's bigger on bottom, and therefore it's Y equals 0. Now how about the X ones, these verticals? It's because the rule for Bob is anything that's a Bob is Y equals 0. Anything that's a sob is a Y equals a ratio. And anything that's a, what's the other one? Bot is none. There are no asymptotes, the vertical kind. Or sorry, the horizontal kind. These are all for horizontal asymptotes right there. If you haven't already memorized that, write it down again. It'll help you to memorize it. Okay, how about the X kind, the vertical kind? They're X equals things. And we just figured it out when we did the domain, kind of, except the domain also had issues with the square root. For the verticals, they only come from down here. So X equals -3. The point is -3 would crash it. And if it crashes it, it's making an asymptote. So if you want a vertical or a vertical asymptote, it is where X makes the bottom 0. So you want to make sure you don't allow it to have -3 in it, because that's making an asymptote. All right. Any other questions about those? Okay, let's test and see if you remember odd and even. Do you remember on a picture? Is this even or odd? That's even symmetry. How about that one? Even. How about that one? You know, you were assuming it's a neither. That's a neither. Because the odd ones have something over here too, but it's not, this would make it even symmetry if I did that, but I'm not doing that. And I'm not doing anything, therefore there's no odd symmetry either. There has to be something down here if it's going to be odd symmetry. Specifically, you'd have to make it go kind of like that. The way you can tell if it's got odd symmetry is if it goes from here through the origin and then pops out the other side and hits the graph. Okay, so if I go from here all the way through the origin, keep on going, is it going to hit? Yes, it would probably have to extend it a little bit, but it would hit right there. So that one has odd symmetry. The classic one with odd symmetry is the John Travolta function. In case you've ever seen the movie, it goes something like this. Anyway, see? John Travolta function. So anyway, that one's got odd symmetry. And if you're going to be doing it without a picture, you have to be able to handle this. F of negative x is equal to, remember what the odd rule is? Yep, that's the odd rule. If you lost it already over the weekend, rewrite it down, memorize it now. It's going to be coming helpful. That's the odd rule. How about the even rule? It's a lot like it. Starts exactly the same. F of x, yes. If you had a choice which to do first, you do whichever one you think is most likely to be. So here's a problem. Y equals x to the third plus 1. Is it more likely to be odd or even? So you check odd first. Everybody, take this rule, write it down, and underneath it make a little T-chart like this, and prove to me whether this thing is odd or not. Just because it's got a cubed in it does not mean it's odd. It might be. All right, your first step, in case you forgot, is you rewrite the function with an empty spot, cubed plus 1. Instead of an x, you use an empty spot. Then you drop in the negative. It totally does matter that you have that parentheses. Because, I don't know if you remember this, but if I didn't have the parentheses, it would look like this, and the answer would be different. Because here, the cubing would happen first, and then you put on a negative. Whereas if it's like this, then the negative is going to get cubed, so it's going to be negative times negative times negative. All right? In fact, in the case of cubing, it really doesn't matter, because it's going to end up negative either way. But you need that empty spot like this. Don't be a rebellious person and try to just stick the number in for x without the parentheses, or there are a lot of times with negatives, you'll screw it up. Okay. Now I'm going to drop in negative x, and negative x cubed is negative x cubed plus 1, and then I'm going to do the other side. Negative, empty spot, drop in f of x. F of x is right here. X to the third plus 1, and now I make both of them negative. Negative x cubed minus 1. Do you see the only difference is a little negative sign? That's why negatives are so important in the class. This is like the linchpin example. All it takes is that one negative, and it proves that it's not odd, because it didn't come out equal. All right? Well, if it's not odd, then we got to check what next? Even. Because you can't just jump to the conclusion that it is neither. Because I don't think it would be even. Nope, that doesn't prove it. You have to prove it. So the rule for evens, underneath this, we go f of x, nope, negative f of negative x, has got to equal f of x. And the cool part is we just figured out f of negative x right here. And so the answer's right there. We don't need to reinvent the wheel. Negative x cubed plus 1. And f of x is so simple. It's just the original one. The original f of x that they gave us was this. Y is also known as f of x, in case you didn't know that. So it's x cubed plus 1. Is that exactly the same as that? No. One little negative sign makes all the difference. So it's not odd. It's not even. Now you've proved that it's neither. Get that?
Wouldn't be taking x minus 1 or
It is exactly the way it is on the board. I know I'm confident I did this one right. All I did is have to copy this down to here, because I already figured it out from the last problem. And then the f of x, I just take the original right there, x cubed plus 1, and drop it in. Okay, so now let's talk about the new stuff. The new stuff has to do with 12 functions that you need to know for Precalc. And I'm not going to have you write all of them down. I'm going to hand out this yellow worksheet that has them on it. Pause for a second while I hand those out. All right, everybody has a sheet now, and I want to start on the side that has the nice straight line on it. Y equals x. Look, it looks like this. Okay. So, everybody, let's answer a few questions about this one. All right, so this one is y equals x. And what's its domain? you've known this function's probably one of the earlier ones you learned, and its domain, it goes forever to the left and forever to the right, so its domain is all reals. You could say it like that. How about the range? How low to how high? Same deal, and you could put a big R for that if you wanted to. That's the same as all reals. Faster. Yep, the R, the big R with the double slash like this, that means all real numbers. Also same as negative infinity to positive infinity. Means the same thing. Okay, anyway, on to the question of is it continuous or not? Continuity just means if I was going to draw this thing with a pencil, once I start on the left side and I keep going to the right, would I ever have to lift my pencil? No, so this thing is continuous. So continuity, yes. And the next question is odd, even, or neither. This one is kind of weird. Definitely not even symmetry, because that would be like folded over that line and it doesn't match up, right? So it's not even symmetry. Is it odd symmetry? Yes, it is. Because if I take a point here and I go right through the origin, will there be another point that's just like it on the other side? Yes, there is. This one is odd. Okay, answer all those questions on the white sheet about that. Okay, that's what we're doing here. Now the next one, we're going to go to the right. Actually, yeah, we're going to stay on the right because the other ones, the squared function and the cubed function, those are going to be really easy for you to tell. They're all continuous. The domains are usually negative, positive, infinity. Some of them are the range, I guess, on squared. You can handle that. Let's move over to the ones you've never seen before. These functions, there's 12 of them. There are 12 Precalc functions. Some books are, it's a big enough deal that on the front, actually on the back cover of the book that we used to use, they have all 12 of them printed there because they are the big ones. You have to know all these functions. We already know most of them. No, I shouldn't say that. You already know about half of them. You are about to learn the other half. Yes, sir. Question?
Why is it all the numbers?
Because it went from negative infinity to positive infinity. If you follow that function, it goes all the way down into the negatives and all the way up into the positive infinities. Okay, moving on to, there's no such thing as positive infinities. Sorry, it goes up to positive infinity. On to the greatest integer function, the one you've never seen before. The greatest integer function looks something like this. Integers are numbers like 1, 2, 3, 4. They're not decimals. So the integer function goes like this. Empty spot jumps up to the next number, 2. Stays 2 for a while, empty spot jumps up to the next number, 3. Stays 3 for a while, jumps up to the next number, 4. And this is an empty spot where it went from where it was ending at the end of its time, and it jumped up to the next number. This was again at 3, and this was at 4. So anyway, bottom line is, obviously, I hope, not continuous. You can't keep drawing it with one continuous stroke of your pencil. You have to lift the pencil up. That's not continuous. All right, its domain. How far does it go this way? Forever. And in case this isn't clear, this does start up again here and goes over here, and then it starts up again. It's not skipping anything. It's skipping things on the y, but x-wise, it's going forever in both directions, so it's all reals. But when it comes to the range, when you're going this way, do you see how if you were, falling down there, you'd end up hurting yourself because you bounce off a lot of those steps there. That one has a lot of holes in its range. So on the range, I would say this guy's range is all integers. But if you think about it this way, that means there's lots of gaps. Everything that isn't the perfect number doesn't work. Like there's gap right in here. See, there's some empty space. It would never be anything between 2 and 3. Okay. Is it odd, even, or neither? This one's a little weird. And you got to trace it back to, let's look at some of our points here. Like one of them goes like this. It has an empty spot. And then it goes like this, empty spot. Now, if I go down from here, through here, and come out the other side, would it touch? I kind of have to stretch it because my drawing isn't perfect, but would it touch another one? Yeah, it would. This appears to have odd symmetry. All right. That's a good question. I said appears. All right, moving down. to logistic function. That's one you've never seen before. It's called the basic logistic function, but you'll just call it the logistic and that'll be fine. And it goes like this. F of x is equal to 1 over 1 plus e to the negative x. And you'll be actually really good at this later in the year. You'll understand what that whole thing means. For right now, all you really need to know is how the picture looks. The picture on your sheet is not awesome because it can't show it as nicely as I can here. It never touches here. It looks like it does on the sheet, but it's got an asymptote at 0. It also levels off. So there's actually an asymptote up here. I actually made it go down. I didn't mean that, but so there's an asymptote below and there's an asymptote above. But does that ever stop it from being continuous? Like would you keep drawing it with your pencil, couldn't you? So it's continuous still. How about this? If I do odd symmetry across the origin, I go through the 0, 0, and is there anything over there for it to touch? No, definitely not odd symmetry, definitely not even symmetry. So it's neither on that. All right, so that one's called the basic logistic. You are responsible for knowing all of these. So when your test rolls around, if they drew you that picture, you'd have to be able to say, oh, I know that one's continuous. Yes? Okay, the domain, you tell me. Can't you tell me that by looking at it? That should be one I shouldn't have to tell you. And how about the range? How low? 0 to not 5. In case you can't tell off that graph, there's one mark on the graph. There's one mark right there. It's 1. The highest it goes is 1 because there's a 1 on top of the equation. Just in case you wanted to know, if I change this to a 10, then it would go up to 10. If I change this to a 7, then it would max out at 7. So it's whatever's on top is the limit. And in this case, the limit is 1. Yes? Can it be 1? No, because there's an asymptote there. Can it be 0? No, because there's an asymptote there. It means it'll never touch it. Yes, that's a good point. Even though the height changes based on whatever number's on top, the asymptote on the bottom is always 0. Okay, you already have seen cubed. You've already seen the absolute value, so let's flip it over to the other side. You may remember 1 over x, but let's talk about it because it's one of the more tricky ones. On the back side of the worksheet now, y equals 1 over x looks like this. And if I was going to help you with domain and range, the domain is how far does it go this way? Negative infinity, how far does it go that way? But does it ever stop along the way? Yes. So it stops at 0. It can never be 0, but it can be everything else. See what I'm doing here? If you want to write that in intervals, you'd say from negative infinity to 0, and then 0 to infinity. The range on this guy, same exact problem. It goes forever down, and it goes forever up, but it stops along the way. So its range has a little blip. It can never be 0. Same exact thing. Can never be 0. Suppose I should just copy it down here. Maybe I'll even say it the official way. That's always the safest way to write it, but the number lines are good. They're really helpful in this unit and a lot of others. So we'll be making lots of number lines to help you understand domains and ranges and all that stuff. Okay, good enough on that one. Is it continuous? Would I be able to draw the whole graph without ever lifting up my pencil? No, it's not continuous then. And is it even, odd, or neither? Definitely not even. Let's check oddness. So if I pick a spot like right here and I go, is there a spot that matches up with that on the other side? Yeah, it's odd. Okay, now let's move over to the right. That's a wavy graph. And there's two wavy ones, sine and cosine. They apparently started with cosine for some reason. I'll usually start with sine, but anyway, cosine. The only difference between cosine and sine is that they've been shifted. Let me show you what I mean. It's a wave that goes back and forth like this. Okay, and sine starts at 0 and then goes back and, starts at 1. Let's see, this is at 1 and this is down to -1. And it oscillates back and forth between 1 and -1. Up and down and up and down and up and down. That's what the sine wave does. And the cosine wave does the same exact thing. This is cosine. That would be sine. Get that the only difference is it's moved over? That's cosine. Sine starts at 0. So it touches at the origin. That's sine. Wait, I'm wrong. I shifted it the wrong way. Dang. I'm going to go like this. Here, that's cosine. That's sine. That's cosine. That's sine. Pretty much identical domain and range. But one of them just starts at 1 at the, when you look down here, starts right there, as opposed to sine starts and goes through 0, 0. One goes through origin, one does not. Sine goes through the origin. Cosine does not. Okay, so it's domain, -infinity, +infinity. It's range, -1 to 1. Same with sine. Why don't you go down to the bottom, the right corner, and do sine at the same time. A lot of the things are the same. If you were to draw it, would you ever need to lift your pencil? So is it continuous? Yes, it is. And then odd, even, or neither. This one's a little weird. The one I have on the board up here, this one's cosine. Can you tell that if I drew a line right down the middle here, you could actually fold it over and it would have symmetry? That has even symmetry. Take a wild guess about sine then. You'd think it's odd, and I'm going to show you, I'm going to prove it to you. Watch. If I take a spot here, go through the origin and come out the other side, do you see I'm going to hit a spot? It's got odd symmetry. If I go here and go, it's another spot. It's got odd symmetry. Because if you fold it over, the question was, why wouldn't it be even? Because if you fold it over across this line right here, it would not match up right. So I take this right here and I say, there's a thing on here that says reflect or flip, left, right. There we go. See how it wouldn't? Ah, it won't let me move this over. Come on, be nice. There we go. See, it doesn't do that. That would be even. Okay. So now let's move down to the, I think square root will be even enough for you. The only thing kids get confused on, I even got confused on square root, is it continuous or not? And remember, does it go forever? It's once you start the graph, can you go forever without having to lift your pencil? And on this one, yeah, it's continuous. Okay, let's go over to natural log. It's in the middle on the right-hand side. Natural log looks a lot like the square root one, but it is different. It's got an asymptote, and again, the drawing that you have on your paper is not awesome because it doesn't really show that it doesn't ever touch. Natural log looks like that. It never touches 0. Okay, so you may want to correct that because it looks like it's touching there at -2. It's not. Natural log looks like this, and there's an asymptote. So then the domain is just slightly different. It does not go from 0. It can't touch 0. 0 parentheses doesn't touch 0. Goes forever to the right, infinity. The range is how low to how high. That's a fairly easy one. Can you tell me the range? Negative to positive infinity, otherwise known as all reals. Both good answers. All reals is just faster to write. Okay. Then continuity. Once I start the graph, I can keep drawing it without lifting the pencil, right? Okay. And then odd, even, or neither. Since there's nothing on the other side of the 0 to reflect through, there's no way that it can be odd. Okay. And it's definitely not even either because I'd see something like this over here. There's not. Okay. So it's neither. Then let's talk about the exponential function. That's the last one we need to talk about because we already talked about sine a minute ago. The exponential also has an asymptote. Also not an awesome picture that you have because it's hard to tell. It looks like it touches. It does not touch. Okay, and exponentials go up forever. They are not limited like that basic logistic one where it had a limit on top. This one never stops. Keeps going up, 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 up. Exponential growth, I'm sure you heard of it. Doesn't, that's the, well, the asymptote is on the bottom. It has a horizontal, like horizon asymptote along here, meaning it'll never touch 0. But it does not have an asymptote this way to limit it. So it's kind of like the basic logistic, and both of them have an asymptote running this way. All right. So on the exponential, what's its domain? Negative to positive, all reals. How about its range? 0 to infinity. Can it be 0? No, because there's an asymptote there. And continuity, once you start drawing it, can you draw it forever without lifting the pencil? Yep. And odd, even, or neither? Neither. Okay, now you know your 12 basic functions. That's the new stuff. The only new stuff today was continuity and knowing these 12 functions. So let's just do a quick, like rapid fire, do you recognize it or not? What's that one called? And by the way, there's an asymptote up here and there's an asymptote down here. Logistic, yep. As opposed to the other one that has the word log in it, which is this one. Remember what that one's called? Natural log. All right. Yes? What? Well, you have to know the name. Yes, but not for this test. We would not ask you for the name. What we would do is give you the equation, and you'd have to be able to say, oh, yeah, I know that one. Like, for instance, let's say the test said, what's the range of this? You'd have to know, oh, that's the same as the 1 over x function, and I know what that looks like. That looks like this. And then where has it been moved? What does that mean? Up 3 or left 3? Left 3. If it was up 3, it'd be like this on the outside. If it's in with the x, then it's a left thing. That would be moved left 3. So I'm going to take this and move it over left 3 and this left 3. And now it's basically, if I ask you the domain and range of that, you'd have to kind of know what the picture is, especially ranges. We a lot of times will ask you range of stuff, and the only way you can do a range is by drawing the picture. So that's why you need to memorize these 12. All right, so let's go through a few of them. You should know them. What's that guy?
Absolute value.
Absolute value, good. How about, what's that guy?
Square root of parabola.
It's a parabola, good. How about, let me think, what is this one again? Logistic. Highest it ever goes, 1. What if I change that to a 10? Goes to 10. Okay. Good enough. All right. So here's your worksheet. I'm going to do some with you. Did I get them to everybody already? All right. What you were doing right there, that was your homework, except it was also in your notes, kind of. So it's good notes to have. You need to know those things, so that did not waste your time. Writing it down like quadruples the chance you will remember it, compared to me just telling you. All right. Yep. All right, so here's your worksheet. Let's start this one together. First question, find the domain and range. Oh, wait a minute, I just handed out the wrong worksheet. Dang. Okay, actually, that's a good worksheet to have, but that is the review for the test, which I wasn't planning to give you until tomorrow. So keep that, and that's tomorrow's homework. Sorry. This one is today's homework. So you're ahead of the game. You have tomorrow's already in case you want to be an eager beaver and get started on it early. It's all review tomorrow, so you could theoretically do it. Okay, so here's your worksheet for today. You count those, see if there's 6. Okay, number 1. On worksheet 1.3, number 1. 1.3.1 is the worksheet. Sometimes we throw a number sign in right there. And this is problem number 1. And it says identify which of the 12 basic functions fit the description given. The 2 functions that are not continuous. I'd say y, you could say f of x instead, equals, give me one of them, int x. Yep, somebody said the integer function. That's the way you can say it the fastest way. And then what's the other one? What also is not continuous? We already got the greatest integer. The 1 over x is the reciprocal function, yes. That's the other one that is not continuous. All the other ones are continuous. Okay? Number 2, let's talk about that one. It confuses people sometimes. The two functions whose domain excludes 0. Remember what that means. That means the picture of it will never touch 0. As you move from the left to the right, not from down to up, from left to right, there must be something where it can't touch here. So like maybe this function, because that can't touch 0, can it? That'd be one of them. What's that one called? lnx. Yep, natural log. That one can't hit 0. What else can't hit 0? No, the square root actually touches that 0. Yep, it does, because the square root of 0 is 0. So it actually, 0 works in that one. Nope, log. We already got lnx. Natural log is already one of our two. What's the other one? 1 over x, yes. Why doesn't 1 over x touch? Because, look, as I move from left to right, it never touches. Okay, remember, as you move from left to right, aren't you going to touch 0 as you move from left to right on the basic logistic one? Watch, I'll tell you when I touch. I just touched. Okay, so basic logistic, when you're going from left to right, this is domain we're talking about. Okay. Anyway, you're going to have to fight through 1 through 9 yourself. They're not incredibly hard. You just got to look on your sheet, see which ones match up. Let's do some more together, though, that might be more difficult for you and more important because they're review for this big test we're about to take. Number 10, use the graphing calculator to find all local maxima and minima. And by the way, that's also known as extrema. I think later in the worksheet they ask about extremes. That's maxes and mins. Both. That's what extrema means. Okay, so basically we're supposed to find the maxes and mins. I hope you know if you have a calculator and we give you a graph and you type it in and it looks kind of like this, can you tell how to find that spot and that spot? You remember with the calculator, you go second calculate max or second calculate min. This one's a max, so you'd go second calculate maximum. You move the little spider thing to the left side of it and then to the right side of it and then right on top of it. Remember that whole process? If you haven't, you better do one in class while it's fresh in your mind. Second, calculate the maximum. The guess is the third question. You hit enter and then it tells you. Okay. Then, number 11. Determine algebraically whether that's odd, even, or neither. This one's a pain in the butt. They gave us a really fairly tough one. Okay, so what's your gut feeling on x minus 1 quantity squared? Do you think that that's more likely to be odd or even? I agree. It's more likely to be even, so I should test that first, because if I find out it is even, then I'm done. So might as well do the test. It's more likely to make you finish early. So you go f of x, oh wait, negative x, is equal to f of x. That's the even rule. Remember that? You have to have that memorized. You're drifting. Stay with me. This is on number, what are we on? 10? 11. Thank you. Number 11. Okay, so I've written my even rule down. Now I'm going to go f of negative x. I rewrite with my t-chart here. On the left side, I rewrite the same function I had with an empty spot where the x was. Do you need those parentheses? Oh, yes, you do. And I know some people think they can just skip that and just write a plain x. It will burn you. I'm warning you. If you have an x, you should put an empty parentheses and then drop in the negative x, because sometimes it matters. All right. So now, what does this mean when I square it? That means times itself. You can't just take both parts and square them. That does not work. We've gone over this and over this, but it still have people do it all the time. They forget you got to do this first outside, inside, last deal. So you actually need to multiply this puppy all the way out and get the answer. I don't want to do it for you. I think you can handle it from there. I'll just start it. Negative x times negative x. x squared, and the negatives are gone. And then you do the outside and the inside and the last and figure it out. Okay, on the other side is just f of x, and that is just x minus 1 squared. And do I have to actually square it? Yes. X minus 1, x minus 1. First, outside, inside, last. You get your answers. Check your two answers. See if they're exactly the same as each other. If they are, you've proved it's even. All right, moving on. Flip the page to 12. That's the exact same kind. You need to make your little chart. Use your odd rule, maybe. It's more likely to be odd than even, so I'd probably start with odd. Okay, number 13. What's the range of that? I'd draw a little picture for yourself. It doesn't even matter. They use 71x just to show you that there's no way you're going to know exactly how steep that graph is, but you don't care because the range on a square root function, does it really matter if it's like this or if it's like this? Isn't the range going to be exactly the same? So you just have to figure out where it starts, and it moved from the parent function. That plus 5.8 has moved it somewhere. You have to figure out where it moved to and then tell the range. Okay, and then it even reminds you about number 19, how to do a regression. Why? It's not on your tests. But which test is it on? The cumulative test. That's why you need to keep doing all your review questions. If you really want a good grade in here, it's all about those cumulative tests, because they can make up for bad original tests. So if you're not keeping up with your review problems, though, then you'll do just as bad on them as you did in the first place. And so your chance at a retake goes away. You know, your only retake chance is the cumulative. Okay, enough preaching. So now, got about 8 minutes left. You've got both assignments, actually. Remember not to do the wrong one. Tonight's is 1.3.1. The one we just started in class. Get that one done first priority, for sure. Because the other one's reviewing a bunch of stuff you don't need to know until after your long weekend. Okay? But you've got it early just in case. And that's all I got.